Hello, so my name is Neil Barton Greenwood. I work for Alert Logic. I've been with them for over 5 years now. And my colleagues are joining us on this talk. So I'll hand over to Justin in a moment. I have a development background and now I'm working as a cloud operations specialist. So Justin, over to you, please.
Yeah, my name is Justin Early. I have been with Alert Logic for 10 years. I have quite an interesting background. My background started in sysops and production support, and slowly over the course of my career has moved into software engineering. And I am, like Neil, on the cloud operations team. And yeah, so we're here to talk to you about CloudFormation.
Thank you. And over to Pablo.
Yeah, my name is Pablo Santamaria, and I have been working with Alert Logic for almost 5 years right now. I had a similar background like Justin said. I was in sysops team some years ago, then to SRE, and now I am part of cloud operations team with Neil and Justin.
So we are going to discuss how we evolved our complex application to a slightly more modern version of CloudFormation. We started off with a nested hierarchy. It was very shallow and very broad because of some limitations with the tool set. So we re-engineered that into a slightly better structure, and we're going to discuss how we went through those steps. Then we're going to talk about some best practices around how you can link different hierarchies by exporting and importing resource references. And then finally, we had some manual steps to stand up the environment, and we'll talk about how we automated those to take out the manual interaction. So we had, the app is about 6 years old now, I think. And with that, we had to solve some issues that AWS has now solved in CloudFormation. So we, in order to make the different microservices that make up the architecture easier to deploy, we started off with a templating system, but this was done outside of CloudFormation. And the parameters for each of those templates were stored within the base stack. And that meant that the base stack itself wasn't true CloudFormation. So it had to be processed by our in-house tool before it could be deployed. And that led to an awful lot of problems. The other problem with that tool set was it would only cope with one level of nesting. So when we tried to group areas of the application, that wasn't possible within the tool, and some of the teams worked around that by storing CloudFormation templates in other buckets and then doing other repositories, and doing remote references. So the actual application itself split and fragmented. And also, because we're doing multi-region deployment, the AMI identifiers are different in each region. So we had a custom lookup mechanism to resolve those IDs. Right, Justin, do you want to start talking about how we split up the hierarchy?
Sure. So we had initially over the years, of course, we slowly built on top of this existing stack. And as microservices built out and they multiplied effectively, we ended up having a huge monolithic core deployment that drove everything. And so as we looked at how we could break this apart and make it more easily consumable by individual engineering teams and make it look sane was the main goal. We started looking at segments of the infrastructure that could be broken out, specifically speaking to the bundle core infrastructure. We realized that everywhere we deploy, we're going to have network, you're going to have IAM roles, you're going to have the core operational support infrastructure. And so we decided to bundle those services into what we call a core stack, and then standardize the exports and the naming conventions that we could then document and hand out to individual engineering teams so that they would be able to consume it in a standardized fashion. And so by doing that, that enables us to enable a pipeline per service to actually granularize deployments of individual stacks. So yes, we have done this. It is repeatable, and that was our initial target when we started. I don't think that there's much else to add to that, other than some stuff that's going to come up in the next slide. So should I move on, guys?
The one thing I was going to say is, if you can use native CloudFormation to do anything, then do it. If you can't, then custom resources is a really good feature. We didn't use those for the templating that I mentioned and the AMI lookup, and it caused an awful lot of pain to go back and try and implement that afterwards. If you're starting from nothing, then it's really easy to do the custom resources. If you're adding functionality in terms of a new microservice or a new set of resources, then adding anything that CloudFormation doesn't support natively directly using a custom resource, that's very easy to do it at that point. Going
Absolutely.
back and adding it later is harder. It's also you've got to watch out with the IDs of any instances you create from the custom resource, because those can't change as you evolve the custom resource itself. Yeah, I think, as Justin said, other than that, we'll move on to the next slide. Or Pablo, have you got anything else to raise on this slide?
No, I think you guys cover everything about nested stats. We can move to the next slide.
This was a fun one.
Yeah, for sure. I think this is part of, for sure, of this. I mean, this made possible the bright nested stats, because once we have the huge stat, as Justin said before, we start moving services out of the main stat, move services out of that repository and that infrastructure. Then we need to start applying export practices, start exporting resources in order to be consumed by outside the stats.
Yeah, because when they're split off, they still need to talk to the ops infrastructure that Justin was mentioning. Right. So the way to do this is by exporting, excuse me, by exporting the resources from the core stack so that they can be consumed.
So one big hurdle that we had here is AWS export naming has to be dynamic within a region. You cannot have naming conflicts, so you can't deploy two stacks with the same name in an export. And so we had to figure out how to structure naming so that it reflected the resource that you were actually exporting, but it also did not conflict with any other stacks that may be deployed. And so in order to do that, we incorporated various dynamic things that come up in CloudFormation, such as region, the individual stack name that was being deployed, and then some additional information in the resource name. But you also have naming limitations. So you can run into brick walls really quickly in this world of exporting the right thing and making sure that it's easily consumable. And easily consumable was the core thing that we focused on as far as what we're going to hand off to additional engineering teams.
And you need to do in the right, and you need to do in the right way from the beginning, because once you export and that resource is consumed by another different resource in a different stat, you need to turn down that resource in order to rename or make any change to the export resource.
Yeah. So any updates to that resource that the documentation says it requires a new resource, you can't do those.
Yeah.
So you have to create a second parallel resource and swap the consumers over to that new one and then tear down the old one.
Any other comments on best practices for?
Yeah, just plan your naming. And
Yeah.
document it and make sure everyone is consistent.
Don't
Please.
forget, yes. Absolutely.
It's the area where you really need an iron fist. You need to tell everyone, you're doing it wrong, stop doing it that way. This is the way it has to be done. Because otherwise,
and if you don't, then you'll come back 3 years later and re-architect the whole thing.
Yeah. Yeah.
That's great.
I think that's it for this slide.
All right.
Yep.
Moving on. So my favorite slide. So basically, as I was initially tasked about a year ago with going off and trying to begin this little effort that we thought was a one employee effort, turned into a huge team effort. And now we are focused on primarily deploying this stuff in infrastructure as code. So as I was going through, I realized there were a lot of manual steps that took place years ago whenever we initially deployed, such as Route 53 entries were manually created and updated by hand. And also, well, let me stop with Route 53. So as I was deploying, I realized, well, hey, there's this magical thing called CloudFormation that can automatically do all of this for me. And so I added Route 53 entries into CloudFormation, but we also have a third-party DNS provider that handles our public DNS. And so I thought, hey, they have an API and I can write code. So I wrote code I wrote code in Lambda in order to update our DNS entries as we deploy stacks. So we can deploy multiple stacks now, and it automatically goes out, updates our name servers for Route 53 in our public DNS, and everything just magically works. We also had a issue where, as I was deploying a stack, I realized we use Amazon issued certificates. And those certificates can be validated programmatically through AWS. And so I wrote yet another Lambda to the rescue again. I wrote another Lambda to automatically validate those certificates through a CloudFormation custom resource. So custom resources, now that we have stepped back and started working through the issues, custom resources, Lambda, and CloudFormation can completely handle the entire deployment from start to finish. We even had a custom resource where, come to find out, one of our teams was manually creating a DynamoDB table in order to deploy their service, but it was a manual step. And so yet another custom resource written in Lambda through CloudFormation, which enabled us to do that. And so now, thanks to the custom resources and time we have put into the research and the development of the CloudFormation and Lambda, we are now able to repeatably deploy our core infrastructure. And it's been a phenomenal achievement.
It's click one command to, and the whole application just appears.
Magic.
The other thing I would say with custom resources, similar to the export and import of the resource names, as soon as you are using a Lambda in a custom resource, you can't update that Lambda. So one trick that is quite useful is to have the custom resource trigger an SNS topic, which then triggers the Lambda. And then you can evolve the code in the Lambda more easily, redeploy it. And because the SNS topic in the middle that joins the two halves together isn't changing, then you can keep using the custom resource as you evolve the code. It took me a while to understand why it was done as an SNS topic at first. So that's a useful bit of information that I learned the hard way.
Pro tip.
Yeah, Christian records are great for this topic and save us a lot of time. I think we are using custom resources as well for pull the right AMI using artifacts, right?
Yes. So we have it's actually a DynamoDB table that lists the different AMI IDs. So we have quite a few services, and we have an internal version number, which is human readable. You actually know what it is. But the DynamoDB table maps from that version number and the service to the particular AMI IDs in each of the regions. And so, we just have a custom resource that looks up that value. So it provides the friendly version number and the service name. And it actually, the same custom resource works for Lambdas and ECS and EKS containers and AMIs. So you tell it which type of artifact you are looking for, the service name, the version number, and it returns back the relevant AWS identifier.
Yeah, that's right.
And manual steps are really bad when you're trying to redeploy and deal with disaster recovery and all of those sorts of things. So work out the steps to automate it as soon as you can. If it's not in native CloudFormation, as Justin was saying, custom resources, they solve all of those issues. Even if you've got a resource where you can configure most of it in CloudFormation, but one or two of the properties aren't yet supported, you can use a custom resource there to set those particular properties. So you pass in the resource identifier and the particular property you want to adjust, and then the custom resource can go and configure it properly.
Yep. And I come from multiple teams that I've been through at AlertLogic over the 10 years that I've been here, but one of them was infrastructure automation. And so automation is in my blood, DevOps is in my blood. And whenever you ask me to go deploy something and I have to do something manual, it makes me cringe. So we're going to find a way to solution around that for sure. Yeah. And Pablo is very much the same way. Neil is very much the same way. If I have to go click something more than once, we're going to find a way to write code to do it.
Yeah, for sure.
I think that about wraps up our presentation. Any final thoughts from anyone?
I think we just covered the main one, which is automate as much as you can. and try to, it's really hard where AWS isn't supporting something in CloudFormation, or Terraform doesn't support something, or whatever infrastructure automation system you're using doesn't support something. But trying to extend it in the native way, rather than writing tools outside to do it, is much better. It makes your life much easier in the future. Yeah, we had an awful lot of technical debt to unpick and pay down to solve all of the automation steps that were done outside of CloudFormation and in an in-house tool. So doing them as custom resources is really the best way of future-proofing your app.
I think that's all we have for you guys.
Yeah, I think so.
Yeah.
Hopefully we taught you something, because we learned a lot.